All right, so lines are really an Algebra 1 concept, but we use them in Algebra 2 a little bit. So anyway, first thing to know is how to find the slope of a line. So one thing to tell yourself or to ask yourself is this: when you look at a line, is it increasing or decreasing? So when you read a graph, you always read from left to right. And so this is the farthest left, and then this line goes up, or increases, so that's increasing. If I were to draw a line between these two, which I will in a second, talking about the slope, when I would look at that line from left to right, it starts here and goes down, so it's decreasing. So if your line is increasing, that means you have a positive slope, and decreasing negative slope. So that's one thing to kind of like figure out ahead of time. So to find the slope of a line, you need to find a couple good points. So one nice one to look for is a y-intercept. So this one has it there. It doesn't always have a nice pretty y-intercept, but this one does. And then there's another point here. Now I can also choose this one there, but if you look at this, they're evenly spaced out, right? Like the stair step, and then it comes around here too. So what I was just doing right there was my rise over my run. My slope is my rise over my run, and that is the change in y. So like delta y, delta means change, and over the change in x, so delta x. So if you're having 2 points, what you can also do is you can subtract the y values, which is the change in y of your points, so y2 minus y1 over x2 minus x1. And you can switch this around. Like you can switch these two values around, but as long as you switch the other two around the same way. All right, so let's take a look. I'm just counting: rise, run, rise, run, rise, run. So I'm rising 3, running 1, rising 3, running 1. So 3 over 1, well, that's 3. So my slope is 3. If I want to figure out the whole equation of this line, I would also need to know the y-intercept, which is -2. So if I were going to do that, I would write y equals 3x minus 2, which we'll talk about on the next page. All right, so if I'm given 2 points, and I don't have a graph, the easiest thing to do is to just basically like do my slope formula, right? So let's pretend that -4, 2 is this 1 point. I mean, I know I have them graphed here, but this one's 5, -4. So if I was going to figure out my slope here, I would take the y values, so like -4 minus 2. And if I did -4 minus 2, this one minus this one, then I have to do 5 minus -4. So 5 minus -4. So that would be, let's see, -6 over 9, so it would be -2/3. So let's see if that makes sense. So if I was going to go down 2 over 3, put me to here, down 2 over 3 here, down 2 over 3, yep, it makes perfect sense. So that's the slope. All right, and I don't really have much else to say. If you have a horizontal line, remember, is going across like the horizon. Like if you look out at where the sky meets the ground, the horizon there. And so a horizontal line is going to be going sideways. Okay, and the equation of that line is y equals, because it's crossing the y-axis, so it's crossing it too, y equals 2. So notice the difference between like this equation and this one. The reason this is like y equals 2 is because the slope of a horizontal line is 0. So it's really y equals 0x plus 2, but we obviously shorten it to y equals 2. All right. Horizontal line, if you were to pick some points on it, pick 2 points, you would say to yourself, the rise to go from one point to the other is nothing, because you rise nothing, say, to get from here to here, but you run 1, 2, 3, and 0 divided by 3 is 0. All right, a vertical line, I don't know, let's put one over here. This crosses the x-axis, so you call it x equals -3. Every point on this line is -3 something, -3,2, -3,3, -3,4. So we call it x equals -3. Just like on this line, this is 1, 3, or 1, 2, 2, 2, 3, 2, 4, 2, 5, 2. The y value is always 2. That's why we call it y equals 2. All right, so x equals -3. So this is an important distinction. This slope is undefined. Or sometimes people say like no slope. but no slope is different than a slope of 0. Okay, because if I was to do my rise over my run here, let's say I pick some points on here. So let's pick this one and this one. So if I do my rise over my run, I have to go up 1, 2, 3. So 1, 2, 3, 4. I rise 4 and I run nothing. So 4 divided by 0, well, you can't do that. That's why it's undefined. Okay. All right, so let's look basically at the equations of lines. So when you have an equation of a line, there's different formats. There's standard form. That's when you have ax plus by equals c. This is a good format for figuring out the x and the y intercepts. So for example, let's say I have, 3x minus 2y equals 6. If I plug in 0 for x, so plug in 0 for x, that means I'm putting a 0 right here. I get left over, because 3 times 0 is nothing. I get negative 2y equals 6, so that would be y equals negative 3. So there's a nice y-intercept. And if I plug in 0 for y, that would be a 0 here and a 0 there. That means I get 3x equals 6, and that would be a nice x-intercept, so 2, 0. So I can see there's the equation of that, there's that graph of that line. I can count out my slope, 1, 2, 3 over 2, positive 3/2. So all that's great. So standard form is like good for finding x and y intercepts because you can plug in 0 very easily and hopefully they turn out to be nice numbers, but they don't always have to. So the next one, slope-intercept form, y equals mx plus b. Remember, m is your slope, b is your y-intercept. This is the most useful for graphing. So if you had an equation, y equals, let's say, I don't know, negative x plus 2. So you could look at that and say, oh, well, the y-intercept is 2, so it's starting at 2. And the slope, remember, there is a 1 in front of here, so the slope is negative 1. So when I do that, my slope is negative 1. I can put it over 1 to help myself out. Down 1 over 1, down 1 over 1, down 1, right 1. And then I have my equation of my line. Okay? So this is the most common one. And usually what you do is, this is already solved for y. So you can also take any equation and you can solve it for y. So if I took this one, 3x minus 2y equals 6, and solved it for y, I'm going to pop that 3x over to the other side. So when I move something to the other side of the equation, it changes the sign. It's a positive 3x, so now it changes to a negative 3x. So negative 2y is equal to negative 3x plus 6. And I'm putting it in front of the 6 because I'm trying to prep for this format right here. And so now I have to divide every single part by negative 2. And so now I have y equals, this cancels out, 2 negatives make a positive 3/2 x, and then this makes a minus 3. And so look, that's the equation of that line right there in slope-intercept form. All right, so there's one last format of of a line is point-slope form. This is kind of like the lazy way of writing an equation of a line, but it's still true. So it goes like this: y minus y1 equals m, and then x minus x1. Now, another way you can write this y1 right here could be moved to the other side. And so you could also write this equation as y equals m x minus x1 plus y1. Okay, so I'm going to show you why that's helpful. So a lot of times when somebody gives you or some information about a line, they might tell you, hey, there's a line, the slope of the line is negative 2, and the line goes to the point, I don't know, how about negative 1, 4. So there you go. So if you wanted to quickly write the equation of that line, you could do this. Y minus y1, this is x1 and y1, these are the numbers you're given right here. y1 is 4 equals m, so m is negative 2, parentheses, x minus, and I'm about to put a negative 1 behind this because that's my x1. You see how I'm filling this in. So if I put minus a negative 1, 2 minuses really changes into a plus 1. Right? And so if you wanted to, you could move the 4 to the other side, the negative 4. So move that over, it becomes positive 4. So negative 2, x plus 1, plus 4. And if you wanted to, you could multiply this out and clean it up. and get the slope-intercept form of the line, okay? But either way, it goes through negative 1, 4. It has a slope of negative 2. So down 2 over 1. And then you can pretty easily see that, oops, it's drawn a little bit off, but you can see how this equation matches, okay? So just to clarify, usually we're probably going to use this format here. Okay, this one's good for graphing. This is good for X and Y intercepts. They all have their uses. A lot of times, like in calculus class, you're going to see this one here get used a lot because it's really quick and easy. Okay, that's it. Yep, that's it.